Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. We've got oranges. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of oranges in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of oranges in any step at all? So that's the challenge. If you'd like to try it, pause the video and see what you can do. All right, well, this pattern seems to be growing pretty slowly, it looks like. We've got 3 oranges in step 1 and only 4 in step 3. And it looks like they've added half an orange in step 2. So I think I can see right off the bat we're adding a half an orange each time. So here's our 3 from step 1, then we added this half orange. And then here's our 3 from step 1, and then we've added another half to the half from step 2. So it looks like we're going up by a half each time. So plus 1/2 and plus 1/2 and plus 1/2. So if I had to predict for step 4, I would say there are 4.5 oranges because there are 4 in step 3 and we add a half. So 4.5 oranges. So we're dealing with fractions here, which is maybe a little bit difficult. We could make a chart and analyze the numbers, but we've already seen here what the difference is between each step, which is usually what we're looking for when we make that chart with the numbers. We're going up by 1/2 every step. And since this goes up the same amount every step, we know it's a linear equation. That's what makes it linear. And we can use this equation, y equals mx plus b, the equation for a line, to model this. And this m, the slope in your line, is going to be the amount it changes every step, the rate of change. And we are saying that's 1/2. It goes up by 1/2 every step. So the start of our equation is going to be y equals 1/2 times x. Now our plus b, we can figure that out by looking at step 1. So y equals 1/2 x. If I put in the step number for x, that's what x represents, the step number, 1/2 times 1 is just 1/2. So that would only give me half an orange. It would only account for this much. And what I would have is 2.5 oranges left over. So I have to add 2.5. And that is our equation. Although I think I'm going to write 2.5 as an improper fraction rather than a mixed number. So 2 times 2 would be 4 plus 1 is 5. So 2.5 is 5/2. So when I write down y equals 1/2 x plus 5/2, that's the same as plus 2.5. I think that's going to make the math easier for the next thing we have to do. But first, let's test this with a couple of other steps. So if I put in 2 for x here, that would be 1/2 times 2 plus 5/2. And 2 times 1/2 is 2/2. And 2/2 plus 5/2 is 7/2. And I have 3.5. Well, that is 1, 2, 3, 4, 5, 6, 7/2. And if I try this in step 3, it would be 1/2 times 3 plus 5/2. And 3 times 1/2 is 3/2. 3/2 plus 5/2 is 8/2. And that's 4. 8 divided by 2 is 4. And that's how many we have in step 3. So this equation looks good. Now let's calculate how many in step 43 by plugging in 43 for x. So y equals 1/2 times 43 plus 5/2. So that's going to give us 43/2. 43 times 1/2 is 43/2 plus 5/2. And that's 48/2. And 48 divided by 2 is 24. So there are going to be 24 oranges in step 43. Well, how did that go for you? Did you get 4.5 for step 4? Did you come up with this equation? Did the fractions give you any headaches? Let me know. Thanks, everybody.